Today's lesson continues our work with Learning Target 1 in Unit 2 on quadratics. In this lesson, we're going to talk about more solving techniques. The techniques we're going to talk about today are completing the square and square rooting. I want you guys to think about, as we go through this lesson, how do you complete the square of a trinomial so that an equation can be solved. To start us out, let's kind of do some very quick and easy solving with quadratics that we haven't tried yet. So far we've tried factoring. In a problem like this, it's not truly really necessary to factor because we don't have the middle term. We don't have the bx in the middle of our ax squared and our c. So we can actually solve this much like we have in the past by just getting the x by itself. Let's do that by adding 16 to both sides. That removes the 16 from the left-hand side. What's left is x squared equals 16. To undo an exponent of 2, to undo a square, is to square root. So now it's time to square root both sides of our problem. And our answer is not just 4, but it could be positive or negative 4. Either of these could be the answer. Why? Well, if you plug these back into the x squared, 4 squared equals 16, and negative 4 squared also equals 16, because a negative and a negative is a positive. So make sure whenever you're square rooting both sides of a problem, you end up with two answers, a positive and a negative version of that number. Let's give that a try one more time. In this problem, we don't have a 0 here, but that doesn't matter. We don't need to do anything with the 28. What we need to do is get rid of this 3. So let's subtract 3 from both sides. And our x squared is going to be equal to 25. Now, to remove the exponent, we square root both sides of the problem. And our x is equal to, again, positive or negative 5. Because the square root of 25 is 5. As we move into completing the square, we need to talk about what a perfect square trinomial is. A perfect square is a number that which you get from squaring another number, such as 9. 9 comes from 3 squared. A perfect square trinomial comes from multiplying two binomials of the exact same thing. So if you were to factor x squared plus 9x plus 9, you should end up with a x plus 3 and an x plus 3. Now, why is this a perfect square? Because another way to write x plus 3 times x plus 3 is x plus 3 squared. So we call x squared plus 6x plus 9 a perfect square trinomial because it comes from x plus 3 squared. We have a negative 8x in this problem and a 16. So that means it comes from x minus 4 and x minus 4. So our perfect square trinomial comes from x minus 4 squared. These are not problems that you will be doing necessarily, but you do need to understand what's so special about these two different trinomials. We can start to kind of fill in the blanks and ask ourselves what number should go here so that we can actually create a perfect square. Well, if you think about 16 and what two numbers can make 16 that are exactly the same thing, because remember we have 3 and 3 and 4 and 4, what and what makes 16? That'd be 8. And it'd be a positive 8. So 8 times 8 is 64, or 8 squared is 64. What two numbers make 20 that are the exact same number? Would that be 10? But in this case, we're making a negative 20, so it's a negative 10. So what is negative 10 squared? 100. So as we continue into the real problems of completing the square, we need to consider this special relationship between 16 and 64, 20 and 100, 8 and 16, and 6 and 9. So here's how you complete the square as a way of actually solving a quadratic. It's kind of a combination of everything we've been talking about so far. First off, this is what I call my make some space step. I literally am just going to rewrite this problem, leave a nice good blank space right here for me to fill in. Now, whatever I choose to fill in into this spot needs to be compatible with the 8. So the number that I want to put into this spot right here would come from thinking, okay, what plus what makes 8? Well, 4 plus 4 makes 8. And what is 4 times 4? That would be 16. So I want to have a 16 put in the blank space that I made by making some space. But don't forget that whenever you add something to the left side of a problem, you have to do it equally to the other side. So both the left and the right get the plus 16. Now, why was this useful? This was useful because now I can actually create my squaring binomial. We know that the number that makes -8 but also makes positive 16 is a -4. And of course we have our x. Remember, these binomials get squared to make a perfect square trinomial. On the other side of my problem, I have 9 plus 16, which is 25. Now I can undo my exponent by square rooting both sides. And I end up with x minus 4. The square is no longer there because a square root and a square are the inverse of each other. They undo each other. And my 25, just like in our early problems, is positive and -5. Two possibilities. My last step is to add 4 to both sides. And what ends up here is two separate problems. I have a 5, a positive 5, plus that 4, but I also have a possible -5 plus that 4. So I have actually two answers. My two answers are 9 for 5 plus 4 and -1 for -5 plus 4. Much like with most quadratics, we end up with two answers. Let's try this again and see what's different about a different set of numbers. So we notice that there's already a C number. This C number is definitely not the number that is compatible with the 6. So in order to make some space, we need to get rid of it. So we get rid of it by subtracting it from both sides. X squared plus 6x. Now I have some space where the 2 once was, and 0 minus 2 is -2. The number that's going to be perfect for this comes from the 6. I want to talk about another way to come up with this number. Yes, I think we can all see that 3 and 3 will make 6. But let's say you had a really difficult number right here. Here are two quick steps to actually create our missing C number, the make some space number. The first step is to take the b and divide it by 2. In this problem, that would be 6 divided by 2, 3. Step 2 is to take that 3, take whatever number you get here, and square it. I get 9. 9 is my make some space number. 9 is the missing C number in my trinomial. So let's add a 9. Remember, whichever you do to the left side, you have to do to the right side. Now I can turn my perfect square trinomial into a binomial being squared. It's x plus 3 because that is the perfect number to add to make 6, but to multiply to make 3, and I have 2 of them. On the other side of the problem, I have -2 plus 9, which is 7. After I created that binomial, it's now time to undo the exponent, undo the square with a square root, but I do it to both sides. I end up with x plus 3 equals, and here's the one thing you got to be careful of, I don't actually really want to work this out. 7 is not a perfect square. There is a square root of 7, but I don't really want to write down some ridiculously long decimal number. So instead, I'm just going to put positive or negative because I'm square rooting, square root 7. Just leave it as it is without having to work it out. This is called getting an exact answer rather than a rounded answer. You get a rounded answer by typing this into your calculator. We want exact answers. Let's subtract the 3 to get the x alone. So our answer is equal to positive or negative square root 7 minus 3. Now I want you to be very careful. Be careful not to write this square root sign too far. If I were to write the square root sign all the way on top of both, it would be very incorrect because the 3 was never underneath the square root. So be very careful that you leave only the 7 underneath the square root sign. So don't write the square root too long. So that's what completing the square looks like, and these are the steps that it takes in order to complete a square and use square rooting as a way of solving a quadratic. If you have any questions, don't forget to write them down in the left column, and I'll see you guys back in class.